Welcome to this video. In this video we will see time temperature transformation diagram. So TTT diagram, C curve, S curve and Bain's curve are all the other names for time temperature transformation diagram. So time temperature transformation diagram is a diagram where we have gamma austenite at above 720 degrees Celsius temperature, and then we cool it. We cool it to get different kind of microstructure like pearlite, bainite, martensite and coarse pearlite, fine pearlite, like that. So from austenite we cools the material, we cools our steel workpiece, and we get different microstructure, and those microstructures have different properties. So we will understand this time temperature transformation diagram in the next couple of videos. In the first video we will have just an introduction of the key terms used in time temperature transformation diagram, and first term is incubation period. So an incubation period is the gamma austenite. When we cool it, it takes some time before it converts to crystal structure with respect to temperature. So when there is a different temperature, it takes different amount of time, and then afterwards it start converting to other microstructure. So that particular period where gamma austenite remains in gamma austenite form only and do not change into other crystal structure, so that period is called as incubation period. Now we'll see how percentage decomposition from 0% to 100% takes place of gamma austenite at different temperatures. So this curve is for carbon percentage of 0.8%, which is eutectoid point, and we'll see that if we cool at 700 degrees Celsius with respect to time. So we have started cooling from here and till this particular time. So x-axis is a time axis and y-axis is a percentage decomposition of austenite into other crystal structure. So this is the incubation period when we cool it at 700 degrees Celsius. So this much time it takes before starting it to decompose it into other crystal structure from gamma austenite. So at 0% composition, this much is the time of incubation, and then it starts to convert into other crystal structure, and this is the percentage. As we rise above, the percentage decomposition gets to other crystal structure, and on this point where 100% gamma austenite is converted to other crystal structure, it stopped converting. So this is the curve for 700 degrees Celsius. Similarly, if we change the temperature, if we take 600 degrees Celsius, so from 700 to 600, the incubation period reduces and it starts much earlier, and it converts to 100% other crystal structure from gamma austenite at 600 degrees Celsius. Similarly, at 550 degrees Celsius, incubation period decreases. So reducing the temperature reduces the incubation period, but after 550 degrees Celsius there is some change. So if we further reduce to 500 degrees Celsius, incubation period increases. So from 700 to 550 degrees Celsius, it is incubation period is reducing, but now after 550 degrees Celsius, if we further reduce the temperature, then to 500 degrees Celsius, incubation period increases. Further, if reduce the temperature 450 degrees Celsius, so at 450 degrees Celsius, if we convert gamma austenite, so here gamma austenite in all the cases is above 720 degrees Celsius, because at 727 degrees Celsius it start to decompose into other crystal structure. So from that we cool at a constant temperature of 450 degrees Celsius, or at any other temperature from at 700 degrees Celsius, we constantly give 700 degrees Celsius to cool it, because our gamma austenite is at above, our workpiece in gamma austenite will be at above 720 degrees Celsius. So we give the environment of 700 degrees Celsius where it cools with a constant temperature of 700. Similarly for 600 degrees Celsius, and similarly for other temperatures. So at 450 degrees Celsius environment, if we keep our material in that, then incubation period increases where gamma austenite starts to decompose at much higher time means much late time than 550 degrees Celsius. And if you further reduce the temperature 300 degrees Celsius, the incubation period further increases and even it crosses 700 degrees Celsius. So these are the curves where we at constant temperature we convert from 0% austenite to 100% gamma austenite. So this is the change which happens at 550 degrees Celsius, and this particular time period is called as a critical cooling rate. So the cooling rate which we gives is a critical cooling rate at this point. From this point 550 degrees Celsius, it starts again bake, incubation period starts increasing. In the next video we will further see how this temperatures we can plot on temperature lines, and we will see the temperature versus time diagram of the same curves. And we will, in future videos, we will discuss more TTT diagram in depth. So this was the starting of TTT diagram.